weeks of snow, that's 2 or 3 weeks less of prep time.
Yeah. I'm gonna go to
Well, it is your math class, so that would make sense.
I don't think my brain can take it today.
Well, unfortunately, that's not an option. I do not plan on doing that, no.
Oh, okay.
You need to use the videos on the website.
Okay.
1, 2, 3. Lisa is late. Sam. Christian was here. Sam is out today. 1, 2. Diego. Grace, Lincoln. All right. Today we're going to spend just a few minutes briefly talking about implicit differentiation again. So that's the new topic we did last time. So just a couple quick questions. Just want your brain to think about that again. So I'm not really going to say anything new on that, but that handout is 39. I think there's 3 of them. And all 3 of those come from real AP questions. So I left that part of the question on there so that you can see this is not my expectations for level of difficulty, but what the College Board's level of expectations are going to be. So we're going to look at those 3 first, and then we're going to move on to the other big topic in Unit 3, which is related rates. So we'll do number 40, which is the notes with a few examples, and then we won't have time to get all the way through 41, but we will at least start it. So we're going to review implicit, talk about related rates for the first time, and then practice as much related rates as we have time for. That is the plan for today. All right, so first implicit question. This one is from the year 2000 test, part of FRQ number 5. And I trimmed off the rest of the FRQ just because it doesn't really matter. But they give us an expression here, and I apologize, this did not print off the best, so might need to recopy it. And the first thing they ask is for you to show that the derivative equals this. So again, same thing we did last time. I'm just showing you a few more real AP questions just to get a little bit more practice in. All right, so to take the derivative of x times y squared, you're going to have to use product rule there. So you take the derivative of x with y squared left alone, and then plus x left alone times the derivative of y squared. And what is the derivative of y squared? 2y and the y prime. Every time you take the derivative of y, you need a y prime. Okay, over here, this also needs product rule. So derivative of x cubed with y left alone, and then plus x cubed left alone times the derivative of y. And what is the derivative of y? Okay, 1 y prime. Every time we take the derivative of y, we need a y prime. The highlighted parts there are what is new about implicit. Now, before I even look at the answer, if I have to do any simplifying at all, it's usually pretty formulaic, where anything that doesn't have a y prime needs to be subtracted over to the other side. And if I distribute this, I would need to add him over. And then you can leave everything with a y prime on the left side. And the reason why that is helpful is if everything on the left side has a y prime, you can factor it out as a GCF. And then undo times with divide. Not that the simplifying is easy, but the simplifying is very consistent from question to question, so that makes it a little bit easier. Now, before I completely move on, I don't know how picky they are about this, so I think you'd be crazy to just go ahead and stop there. I think it's worth go ahead and putting this one first, just because they put it first. And then my denominator already looks right, so I'll leave it alone. And as far as I can tell, when they ask you to do this on an FRQ, they always give 2 points. 1 point if you remembered all the implicit. So 1 point if you had these y primes or dy dx's where they needed to be, and then 1 point for the rest of showing that that ends up being what they said it was going to be. Okay, so from the first one, anything about that question that jumps out at you? Bless you. You're all okay with that? Okay. All right, then let's look at the next one from 2001. Now, I didn't like go through the history of all of the released FRQs and pick out every single one of them or anything like that. So don't think that, oh, they haven't asked us since 2000, so it's not likely. Because it looks like the very next year, 2001, one of the questions ended up being some implicit differentiation. Now, it doesn't really look like it, but you'll see why it ends up being implicit in just a second. So this question, this was just part 2. Again, I took away the parts that we haven't learned yet. But they tell us this is differentiable for all numbers. This point is on the graph. The slope is given by this derivative, and we're asked to find this. Well, what is this asking for? Okay, so they gave us the first derivative, and they want us to find the second derivative. So we need to take the derivative of this, and then plug in the point 3, 1/4. So when I look at this, here's the first derivative, so now I'm doing the second derivative. To me, this looks like product rule again, so pretty common. Take the derivative of y squared, which would be what?
2y.
2y and y prime, because I took the derivative of a y, times the other stuff left alone, plus, then leave the y squared alone, times the derivative of the other stuff, which would be, what's the derivative of that stuff? Negative 2. Okay, do I need a y prime here? No, because I didn't take the derivative of y that time. I only took the derivative of y once, so there was only one y prime. So if we want to know the second derivative at this point, 3/1/4, that means I can plug in a 1/4 everywhere there's a y. Y and y prime are two different things, so don't plug 1/4 in for y prime. I can plug in 3 for x. And we're left with this. What does this stuff go to?
0.
Okay, so if this is 0, times something, times something, times something, all of this really just goes to what?
0.
Okay, and then plus 9 times negative 2. So it looks like negative 18 would be our answer. Now, what if this had not gone to 0? How would I have known what y prime is at 3/1/4? How could I have plugged the number in here? Yeah.
You could plug it in what's in the original derivative.
Right. So if you needed to know what this number came out to be, I didn't just because it got multiplied by 0, but you could plug it into the derivative and then substitute that with a number. So it didn't say anything about implicit, it didn't give us the answer to start off with, but because we took the derivative of a y and we needed a y prime, we did implicit in there. Yes, Dylan?
Wasn't there a y squared there instead of an x squared? You just did 9. So wouldn't it be 1/8?
This?
No, toward the end of the problem.
Here?
You plugged in
Yeah.
x instead of
It should
y
be-
for that one.
Oh, you're right, you're right. Thank you. This was supposed to be y squared times negative 2. And 1/4 squared would be 1/16. 1/4 times 1/4. And then so 2 reduces with 16 and negative 1/8. Does that look better? Sorry, I don't have the answers in front of me, so I couldn't normally catch up. So it doesn't say anything about implicit, but we still needed to know how to take the derivative of the y. That was highlighted there. Okay, are we good enough with that one? We can move on. Because if you got a question, you need to ask, because we are about to move into related rates, and we just won't talk about implicit much until the test review. Okay, then let's look at one more. Again, just one that I had found, not anything more special about it than others. But in 2004, FRQ number 4, the very first thing they ask you to do is to show that the derivative equals this. Now again, it doesn't say implicit, but when you start going through and doing the derivatives, the derivative of x squared is 2x. The derivative of 4y squared, you get to do just like regular power rule, but you're doing implicit because you're taking the derivative of y, so you need a y prime. And over here, unfortunately, we're going to have to do product rule for this x times y. So derivative of x with y left alone, and then x left alone times the derivative of y. Took the derivative of y again, so I need another y prime. If you forget it even once, it doesn't matter how long you're going to spend on this question, you're never going to get it to be equal to that, because you're going to be missing some of that. So that is the most important step. So are you guys okay with that first step? Okay, then to finish, we should get all the y prime stuff on one side, all the non-y prime stuff on the other side. That way, if everything on one side has a y prime, we can factor it out as a GCF. And if y prime is equal, or y prime is being multiplied by this stuff, we can undo multiply with divide. And if I needed to move the terms around and stuff to make it look identical to that, then I probably would. Again, I don't know how picky they are there, if they would not give you that second point, but. So 1 point, if you can see and do both of the y primes, and then 1 point for showing the rest of it, and then it comes out to the answer they expect it to. Typically, that's how it's scored. You guys okay with that? Now, on one hand, last time I saw you guys, I did try to scare you just a little bit with the showing you a full FRQ. If you remember, there was a part B and part C that were fairly tough, and I talked about how all of these are scored out of 9. But what I want you to really see here is that, you know, if you are really good with implicit, which you certainly can be, it's not that much work, it doesn't take that much practice to get, and you are fortunate enough to get it on your AP exam this year, which I have no idea if they're going to put it on this year's, but they probably will. Having 2 out of the 9 points doesn't sound like a lot, but it actually goes quite a ways. Out of 9 points, how, like, what do you guys think that the average for FRQs typically are for us?
4, 5.
Sometimes between like
3.
Roughly between 3 and 5 points, depending on how hard of one it is. Now, they scale our AP exam, so if they're all really hard ones and all the averages are low, you need less points to pass. But, you know, let's say the average on this one was, I don't know, I could look it up, but if the average on this one was 5 and you can already get 2 of the 9 points from part A, then that relieves a lot of the stress and pressure to execute parts B and C, which might be harder. So, okay, that's all I want to talk about implicit for today. Just wanted to do a quick little recap of that to help that stick in your head a little bit longer. But if there's any questions on this, now would be the time. Okay, then let's move on to related rates. Related rates actually have some very similar stuff going on with them as far as the derivatives go. These question types take a lot more practice though. These are all really, honestly, this might be my favorite topic in all of calculus because all the questions are very real world relevant. And we can solve for some pretty interesting stuff with very little calculus knowledge and very little algebra work. But every question does kind of seem different. So at the top of this page, I have some tips written out. Going to make sure we read the question carefully, make sure we know what information is given to us and use it. Oftentimes drawing a picture will help us figure out what's going on. Define the variables. So if they tell you how big a radius is, say r equals this, stuff like that. We're going to have to think of an equation that pulls all of the variables together. And when we do related rates, we are taking the derivative with respect to time. That's very important. These are things that change over time. So now we're not taking the derivative with respect to x. X is not our independent variable now. Time is our independent variable. So every single time that we take a derivative in related rates, unless it's a t, we're going to need that variable prime. Just like when we took the derivative of y with respect to x, we needed a y prime. Now if I take the derivative of y with respect to t, those variables don't match, so I'm going to need a y prime. if I take the derivative of volume, or v, with respect to time, I'm going to need a v prime. If these variables don't match, we have to keep up with the part that is similar to implicit. All right, and then plug in the information and then solve for what they want. Okay, so the first one is about a snowball. So what shape, what mathematical shape is a snowball if we're talking about, okay, it is a sphere and it's melting at a rate of
10 cubic feet per minute.
okay, and it's melting, so that would be negative, rate of 10 cubic feet per minute. You really do want to write the units here. Now, but what is that? Is that the radius of the sphere? Is that the surface area of the sphere? What?
Surface area. Radius.
Not cubed.
Oh, volume.
Okay. Well, volume is how much space something has to hold. This is how volume is changing over time. So this is actually v prime, volume prime. This is the derivative of volume, or you can write it like this. That's dv over dt. These are the same thing. It's the rate of change of the volume. Okay, they would like us to figure out the rate that the radius is changing. So they don't want me to find r, they want me to find r prime, which is the same thing as dr over dt. Specifically when the radius is 2 feet. When r is 2 feet. So in those tips above, it said draw a picture. Well, I don't think we need to do a picture of a snowball. But you, some point, I have this highlighted. Find an equation that relates these variables together. So snowball fits a sphere. We know something about volume, something about radius. Do you know the volume of a sphere formula?
4/3 r cubed.
Very good. 4/3 pi r cubed. This is one that you do not have to know for the AP exam because they give it to you when you use it. You will certainly use it. But that is this. I thought of a geometry formula that ties in volume, radius for that type of shape. Now, I've not done any calculus at all yet. I mean, I guess it helps to know that the rate is something prime, but I've not really done any calculus. So now what I need to do is I need to take the derivative of this. The derivative with respect to time. So if I just try to use the power rule on v, it's just like doing the power rule with x. What's the derivative of x? Then the derivative of v is 1. However, I just took the derivative of v with respect to time. I have to include that, just like we have to include the y prime when we do implicit, because those variables don't match. And dv dt is the same thing as v prime. I can't just take the derivative of the left side without taking the derivative of the right side. And most of this is just a constant. So what do you think the derivative of the right side would be? What did you say? Okay, bring this down. 4, I agree with. What else? I agree with.
R squared.
R squared I agree with.
dr over dt.
Very good. I just took the derivative of r and it was not with respect to r, so I have to keep up with this dr over dt, also known as r prime. So some questions, you're going to have all the information you need. We're going to plug in. They gave me v prime is negative 10. They gave me r is 2. and they want me to find r prime. Well, once I plugged in the stuff given to me, it looks like I have everything except for what the point of the question was. So now we are on to algebra. I could multiply these. 4 times 4 would be 16, times pi would be 16 pi. Divide both sides by 16 pi. And then we could reduce this to maybe be like -5 over 8 pi. And then sometimes we need to keep up with the units. So what kind of units do you think r prime might be? Well, what kind of units was r in? Okay, it was in feet, but r prime means the rate of change of r. So it's got to be per an amount of time.
Minute.
So if this was in minutes, this would be in minutes as well. So simply knowing that that's a sphere, knowing how fast the snowball is melting the volume, at the exact instant when the radius is 2, I can tell you at that exact moment, this is how fast the radius is shrinking. So something that you basically can't do in your head, but if we work through the problems, define our variables carefully, figure out the geometry formula that combines all that stuff, take the derivative of both sides, making sure that you realize you're taking the derivative with respect to time. So when you take the derivative of v, you need a v prime. When you take the derivative of r, you need an r prime. Plug in the stuff given to you and then solve for what they want. So the next question is probably not a sphere, but it's going to have a similar structure to how to approach the question. So, all right, so let's move on to that. Baseball diamond is 8,100 square feet. CJ runs from first base to second base at 25 feet per second. How fast is he moving away from home plate when he is 30 feet from first base? Okay, so the last question, I didn't feel like I needed a picture because I know what a snowball looks like, but in this one, it might be helpful to sketch my baseball diamond. And I need to start to try to collect all this information. I need to know what all of this stuff is. So it says the baseball diamond is 8,100 square feet. So to me that sounds like the area. Well, it's certainly the area because of the units, I'm sure of that. Square units is always going to be area. Cubic units are always going to be volume. And linear units are always going to be lengths. Okay, CJ runs from first base to second base, so he's, I don't know, somewhere between first and second base, and he is running at a speed of 25 feet per second. So try to add that to my picture. But what we want to know is how fast is he moving away from home plate. So how many feet per second is he moving away from home plate at that instant? At the instance when he is 30 feet from first base. So when this length is 30 feet and he's running that fast, we should be able to compute how quickly he's moving away from home base. So I think I defined all my variables. So I kind of just have to dive into this. What geometric shape do you see in this question that we might need to use? Okay. More specifically, a right triangle. Well, what kind of geometry formulas do you know that work with right triangles?
Pythagorean theorem.
Okay, and that is a common one for these question types. Call one of the legs A, one of the legs B, and one of the hypotenuse has to be C. Now, just like above, I started with the geometry formula, volume of a sphere. This one you don't have to memorize. They do expect you to know Pythagorean theorem. They don't provide this one for you. But at some point you've got to take the derivative here. So what is the derivative of a squared with respect to time? Good, 2a, and I just took the derivative of a with respect to t. Not the same variables, so you have to put an a prime. The only time you don't need the prime is when they're the same variables, like x and x. Okay, b squared is the same idea. Power rule, but I just took the derivative of b with respect to time, so I need a b prime. C squared, same thing. Power rule, and I just took the derivative of c with respect to time. Now, what I hope, like question 1, is that I know all of this stuff, I plug it in and solve for what I want. But sometimes we're going to have to do a little bit more work. So I know this is, well, first off, does everyone see that we could just divide everything by 2? Okay. So I'm just going to do that just because it makes our numbers a little more manageable. Okay, do we know the length of A yet? Okay, do I know the rate of change of A? This is what I'm calling A.
It's not changing.
Okay, so then the rate of change of A is
1. 0.
0. Okay, so A times 0. So who cares? That's going to 0 anyway. Plus B. Do I know the length of B?
Yes.
What is it? Okay, I just need to make sure you're looking at the right thing. Times the rate of change of B, which is,
25%.
okay. So, I don't know. Can someone do this in their head for us? 250 times 3 is
750.
750.
Genius mathematician.
Okay, do we know the length of C yet? Okay, so then I guess we have to leave it C. Do we know the value of C prime? Okay, well, one of these things, it should make sense that we don't know because it's the point of the question. Which one of these two is our ultimate goal here? Okay, so it makes sense that we don't know this one yet, but we have to dig a little bit deeper to find C. Question 1, we had all the stuff we needed, we just plugged it in and solved for what we wanted. But there's enough information for us to solve for C, it's just not given to us yet. So we've not used this. Since a baseball diamond is a square, if the area is 8,100 feet squared, what does that tell us about each of the side lengths? 90?
90 feet.
90 times 90 is 8,100?
What's 9 times 9 again?
81?
Oh, well, yeah.
Okay.
You're tripping me out.
But I'm not just questioning you. Is everybody okay with why this has to be 90 by 90? Length times width. Okay. So I guess technically, if I had needed to know the length of A, it was actually 90. It didn't matter here because it got multiplied by 0 anyway. But now that I know all the side lengths are 90, how could I maybe find this length? Good. I know the leg is 30, a leg is 90. I could solve for the hypotenuse. So to find C, we've got to sidebar over here and say, within that right triangle, I know leg squared plus leg squared equals hypotenuse squared. So C is the square root of 9,000. And what times what gives us 9,000? 30. 30 times 30 gives us 9,000. So I have, huh?
Wait, yeah, no, it's not.
Okay, what should it be then?
3,000?
Oh, it's always-
No, I'm an idiot, sorry.
You're right, that didn't come out to a nice whole number.
I don't think you can. That's 3,000.
I think it is a irrational number.
Okay, well, you guys agree that square root of 9,000 is the same as 3 times the square root of 1,000, right?
Yes.
I agree with that.
Okay, let's try to simplify this more. 1,000 is like,
250 times 4.
okay, that's not helpful, but,
You can do like 100 times 10.
Square root of
okay, so
250, You know?
this is
Oh,
like
yeah, that's even
10
better.
times. So it looks like the square root of 1,000 is like 10 square root of 10. I don't remember if the answers to this was like decimals or what, so I'm going to try to keep up with that. But the point is, I didn't know one thing I needed to solve this equation, but there was enough information to go and seek it out. Now that I can plug in how big C is, if I'm trying to solve for C prime, I just do undo times with divide. So the answer is going to be 750 divided by the 30 square root of 10.
Can we short type this around that part?
To leave it like this?
Oh, well, you can do divide by 30. That's like 25 over square root of 10.
Yeah, I'm not worried about the simplifying. Obviously, you guys might have to simplify it if it's multiple choice, but... And for the same reason, I guess I could have not simplified this until I saw that I had to. Okay, so what I need you to get out of this, again, it takes several of these before you feel comfortable. The next question's probably not a square, but you need to think about it, the format of what we did. A picture helped this time. We read through here, we tried to define all of the stuff that was given to us. I either put that on my picture or wrote out what it was. We had to think of a geometry formula that tied all that stuff together. We had to take the derivative of that geometric formula. We plugged in the stuff they gave to us. There was one thing they didn't give to us, but with a little bit of Pythagorean theorem work, we could find that, and then we could solve for the thing we want. Now, of course, if you're really interested in this type of question and this exact problem, you probably want to think of this as a decimal. So I went ahead and typed it in. It's about 7.9. So when he's 30 feet away from first base, if he's running at 25 feet per second, at that exact instant, he's running about 8 feet per second away from the home plate. That's what we just figured out. So not an easy question, not a short question, but it's certainly achieving something that we couldn't just do with brute force in our head.
Oh, well, yeah, he's already right.
That's insane.
Get him in the Olympics.
Hmm?
Get him in the Olympics with that kind of speed. 5 feet per second.
Well, it's 8 feet per second away from home plate. That's way down here. So he's almost running directly away from it. So
But not just that, he's running at 25 feet per second.
is that fast?
That is fast.
Yes,
Okay.
incredibly.
That's incredibly fast.
I didn't make up the
It's
question.
like impossibly fast.
Yeah.
Usain Bolt playing
Running
baseball.
25 feet per second is pretty much impossible.
I didn't make up the numbers.
Yeah, I could run like not that
I think
much.
25 feet per minute.
I could run like.
Mr. Townsend, I don't think any of our wheels are turning today.
Any of your wheels are turning?
Like our reins on our brain.
Oh, well, I can't help you with that. You have to learn to drink coffee.
But even that's kind of fast. I think we're focusing on the long thing. I guess that's true. You go run 5 per second.
All right, let's reset here.
Yeah.
Okay, so new question, probably new geometry formula, but the approach to the question should be the same. A stone is dropped into Lake Fayetteville. Again, I didn't make up these questions, but this one probably won an AP question if it says Lake Fayetteville. Causing concentric circular ripples. So what does that mean?
Circles.
Okay, more specifically.
Oh, big circle. Many circles. Concentric circles.
Okay, so circles within a circle, like when you drop a pebble into the water. So there's my picture.
It looks like a target.
The radius increases by 2 meters per second. So 2 meters per second is what?
6 feet per second.
Okay, Christian.
Sorry.
No.
Sorry.
No more. I don't want to hear your voice again.
Unzip.
Good.
Is it R prime?
It is the rate of the radius, so that has to be r prime. Or if you'd rather, dr over dt, same thing. We want to know how fast the disturbed area grows. So what are we trying to find? Am I trying to find the area of the circle?
The circumference.
The area.
Area.
How area is changing, so area prime. Area is just a one moment in time. It could be this big. If I want to know how it's changing or how it's growing, it's A prime. How is it changing over time? Specifically, when the outer ripple has a radius of 5 meters. So notice one time they told us the rate of the radius, and another time they're telling us how big the radius is. We have to know the snapshot in time, because this area changes depending on what time you're looking at. Okay, so we've got an idea of what the picture looks like. We've got a few of the variables. We have to think of a geometry formula that's going to tie all of this kind of stuff together. Yes, Christian?
Pi r squared.
Pi r squared is close, but that's not an equation.
Oh,
1/2 pi r squared.
A equals, the area is pi r squared.
yeah. What? That was close enough.
Okay, I know I need to plug in some of this stuff, and I need to solve for A prime, so what do I need to do to this? And that's the calculus step. The derivative of A, you might think is 1, but we're taking the derivative of A with respect to time. So we need a dA over dt, or A prime. Over here, you can do power rule. You can bring the 2 down, lower the power by 1, but I just took the derivative of r with respect to time, so I need an r prime. R and t are not the same variable, so I have to keep up with that r prime. If I start plugging in, I don't know what a prime is, because that's what I'm searching for. 2 is just a number, pi is just a number, r was given to me, r prime was given to me. Now, I did not do a good job of this on the first couple questions, but that's because there's so much going on anyway. But it is kind of helpful if you do keep up with the units, because now I've got 2 times 5 times 2, which would be 10. I've got an m times an m, so meters squared, which makes sense. Area always has square units, but since it's a rate, it should be per an amount of time. And you don't have to think about those units if you just keep them in your work. So
Where do you get 10 from?
2 times 5.
Oh, it'd be 20.
Oh, times another 2 would be 20. And a pi, so 20 pi meters per second. Meters squared per second.
Ooh, this is pretty interesting.
Yeah, they are interesting questions.
If I draw
That's why I like them. But now, to be fair, it is kind of hard to measure how fast the radius is increasing. Like, that's not something that you could measure very accurately, very easily. But once again, a picture helped. We defined the variables. We tried to think of a geometric formula that ties this stuff together. Question 1 was the volume of the sphere. Question 2 was Pythagorean theorem, right triangle. Question 3 was area of a circle. Could be totally different things, but when you take the derivative of both sides with respect to time, which creates the a prime and the r prime, we were able to just plug in the stuff we had and solve for the thing we didn't have that they wanted. So that's the part that's been consistent question to question. All right. Up next, all edges of a cube are expanding at a rate of 3 centimeters per second. So there's my cube. Something is 3 3 centimeters per second. But what is that? Is that the volume? What is it? Well, volume would have to have cubic units. So if this was centimeters cubed, then
Surface area.
okay. Area has squared units.
The lines, like
Width.
width.
Okay. So I'm going to call that S. So this is S prime. The rate of change of the side lengths is 3 centimeters per second. They want us to find how fast the volume is changing. So they're not asking for V, they're asking for V prime, the rate of it. Specifically, when the edge, which I called S, is 1 centimeter. So sometimes it's easy to overlook some of that and we have to reread the question and dig a little more information out of it, but we need a formula that ties this type of stuff together. Side lengths, volumes, and cubes. So what do y'all think?
Length times width times height.
Okay, but since it's a cube, let's not call them length, width, and height. Let's just call them all S. So side times side times side.
S cubed.
That's the volume of a cube. There's our geometry formula that changes question to question. Number 1 was sphere, number 2 was a right triangle, number 3 was a circle, number 4 happens to be a cube. At some point you've got to do some calculus. So take the derivative of this side with respect to t, which is why you need a v prime. Take the derivative of this side with respect to t, and you would get what?
3s squared s prime.
Very good. 3s squared s prime. Power rule, and then this is basically chain rule, implicit. There's going to be one thing you don't know, because that's what you're trying to solve for. The other things, we hope we have all that information. I know s is supposed to be 1. S prime is supposed to be
3 meters per second. 3 centimeters per second.
okay. And notice I kept up with my units here to help you see this, because it will help you with the units. Looks like I left was 3 times 1 squared times 3, which would be 9. And what is centimeters squared times centimeters over seconds?
Centimeters cubed over seconds.
Which makes sense for volume, because volume always has cubic units. And if it's volume prime, it's how it's changing over time. So there needs to be a time unit. So if you keep up with the units in there, then it's a lot easier to confirm that you got it all. Alright, so once again, I have to just keep beating you over the head with this to make sure that we emphasize this. Picture helped. Define the stuff that's given to you. Think of a geometry formula that ties it together. Take the derivative of the geometry formula with respect to time. Plug that stuff in and solve for what they want. Sometimes that's all you have to do, like questions 1, 3, and 4. Sometimes there's still one more missing thing that we have to do a little bit more work for, like question 2. But even though every question is different, that part of the questions is predictable. All right, so question 5, I'll read it to you, and I'd like you to try to make the picture as we go through it. We have a ladder 25 feet long leaning against the wall of a house. The base of the ladder is being pulled away from the wall at a rate of 2 feet per second. How fast is the top of the ladder moving down the wall when the base is 7 feet away from the wall? So just try to make a picture and label some of those numbers on your picture and see how close you get. Okay, I'm sure my picture is better, but okay. We have a ladder. He is 25 feet long. The ladder is being pulled away from the wall at a rate of 2 feet per second. I want to know how fast is it moving down. So how many feet per second is the top of the ladder moving down the house? Specifically at the time when the base is 7 feet away from the wall. Your picture looks something like that. Okay, so if we tried to define some variables here, that's kind of hard to do. We don't know what R equals or V equals or anything like that. So really the best we can do is put them on our picture here. Now that I have our picture, what geometry shape do you think we're going to be working with? Okay, a right triangle. And what formula do we know for right triangles that pulls together some side lengths?
Pythagorean theorem.
Okay, so it's probably this. This is the most common type of related rate. Just like all of the questions, you need to take the derivative. So it's just power rule with chain rule. You really need to understand though why there's an A prime, B prime, and C prime. Related rates are always with respect to time. A is not the same thing as T, B is not the same thing as T, and C is not the same thing as T. So we need those A prime, B prime, C prime. Now, because there's all a 2 here, most people, it doesn't really matter, but most people just divide everything by 2 just to make the numbers a little bit smaller. Okay, which one of these sides has to be C?
So 25.
Hypotenuse has to be C. The other 2, doesn't matter which one you call A and B. So let's start plugging in the stuff that we know. If I call this A, do I know the length of A?
7 feet.
7 feet, okay. Do I know the rate of change of A?
2 feet.
Again, it's a little bit better if I keep up with units, but just to make it a little cleaner, I'm going to skip that. All right, do I know the length of B?
No.
Okay, so let's leave that B. Do I know the rate of change of B?
Negative something. No, we don't know.
We don't know that. If we knew that, we'd be done. That's what the question's asking for, right?
Yeah, I forgot about that.
So it makes sense that we don't know that one. Okay, it wants us to plug in the length of C, which is?
0. Well, 25.
Your ladder's not 0 feet.
Well, I was thinking ahead. I was the rate of change is 0 because it's 25 all throughout, and then you multiply that by 0, so it's 0.
The length of the ladder is 25. What's the rate of change of the ladder?
Let me guess. 0.
It is 0. The ladder is not changing lengths. Now, if I want to solve this for B prime, do you see how I have a problem? I don't know B or B prime. I don't quite have enough information yet.
How tall's the house?
So, like the baseball question from a minute ago, just because I don't have all the information doesn't mean I can't figure it out. If this is a right triangle, when this is 7 feet and the hypotenuse is 25 feet, we could do Pythagorean theorem to find this length at that moment. Or if you know your Pythagorean triples, I believe that's a 7, 24, 25. So that is an example of one we had to just dig a little bit deeper on. We actually had to go out and figure out what B was. But then we can subtract the 14, divide both sides by 24. I could divide both of these by, just trying to reduce, by 2. And what kind of units should this be? Oh, yeah, I wrote it right up here. I already thought about that. So the fact that I made that kind of helps out. It's not a length, which would be feet. It's a the rate of change of a length. So it's got to be a distance per amount of time. Okay, and all of that mess that Christian was saying, he did say one thing in there that was worth something.
Thanks.
Okay, you realize that this was needed to end up being negative, right? Because it's going down.
Correct.
One thing you do need to be careful about, depending on how this is worded, like when this says how fast is the top moving down the wall, so that kind of implies negative. So as a multiple choice question, depending on the wording, you might still pick positive 7/12ths, and the negative is being taken into account of by saying it's going down. So the wording matters. Okay, so again, totally different question. I guess not a different geometry formula, but similar structure. The only way these questions are going to get easier to you is to realize picture helps with most questions. Labeling the picture helps with most questions. All questions you have to think is a geometry formula that ties it together. Bless you. You've got to take the derivative of that, remembering the highlighted stuff for the rate of change. Plug in the stuff they give to you. Hope that that's enough to solve for what you want. But if it's not, then there should be enough for you to solve for the rest of it. Okay, I'm going to cheat a little bit on part B because it says 15 feet away from the wall. So if I change this to 15, I'm just going to reuse the picture here.
Oh, you can skip to that one part.
I know it's Pythagorean theorem. The derivative's going to be the same. I could still divide everything by 2. A is still 15. Or I'm sorry, A is 15, and the last time it was 7. A prime is still 2. B is still 24.
Oh, no.
No, it's
It's like something small.
It's 20.
C is still 25, and C prime is still 0. Everybody okay with that?
Oh, yeah, you're right.
Yeah, but if we change this length, it does change this length, because now Pythagorean theorem, I don't know, I'm not going to try to do that in my head. Hypotenuse squared minus leg squared, the square root of that comes out to be 20. It's weird. Actually, this was B, sorry. You guys understand why this length is changing?
Yeah.
Because if this length's changed, and I had to redo the Pythagorean theorem part, but really that's all that changed, because this part of the question changed, this part of the question changed, but everything else was the same. Got 30, could subtract that over. If I'm trying to figure out the rate of change of B prime, divide both sides by 20. And so since this is the rate of change of B, I need to know a distance per an amount of time. So the distance in that question was feet, and the time units were seconds. But B is a length, so it should be feet to the first. Area would be feet squared, volume would be feet cubed, length should be feet to the first. And of course you could also put the units in here, and then when you multiply the units you should see that you get the same thing. So that's another option.
We're always off on a tangent.
Somebody is, not me.
Hey.
Okay, so next up, let's move on to our practice worksheet here.
Which number was the notes again? 40?
Townsend,
Is 41 holds
out
on
of
to
curiosity, if you have a fraction as a rate, can you, like for example, our last problem was -3/2 feet per square.
Okay.
Can you put like -3 feet over 2 seconds, or is that?
You could, yeah. Same thing. This is 41. Kirsten, you got what you needed?
Oh, yes.
All right, so this is just one we're going to start today. You don't have enough time to finish. But I highly suggest you guys do this on a separate sheet of paper. Some of these questions you can squeeze into the side. Even if you think your handwriting is nice and neat and that's good enough, if you ask me for help and you've got a bunch of stuff squeezed in here, I'm not going to be able to follow it, and I'm not going to give myself a headache trying to read it.
I don't want your help, Mr.
Now, the first 6, the answers to the first 6 are down on the bottom of the page. So when you work question 1, if you don't end up with 8 pi feet squared per second, and you can't see why, then you should ask and let me help you. This skill just takes a lot more practice before you feel comfortable than implicit does. But you need to just feel like you're making progress. However much you struggle with question 1, hopefully a little bit less on question 2, hopefully a little bit less on question 3. This is not homework, but eventually I will ask you to finish it. So the more you get done today, the less you will have later and eventually for homework. So please do them in order. You guys are welcome to compare it and work quietly with your neighbors. And I will be coming around and helping as well. But again, I can only help you if I can read your work. If you're cramming it in this, if you need paper, I can get you paper. But if you try to squeeze it into this little bitty space, and I can't read it, then I'm not going to help. Once you get past page 1, the rest of the questions, I believe, are real AP questions. So most of those are multiple choice. You guys need to make sure that you save your work. If you just circle the answer to question 4 and there's no work for it, then you won't be getting homework points for that. I need to see your work that goes along with it. All right, and you guys got about 30 minutes, so try to get as many of these done as you can, and just try to get as comfortable as possible for today. This is not homework. The only homework is to turn in your book assignment from last class in the Google Classroom. I will also try to make a list of geometry formulas they expect you to know. I know for sure they don't expect you to know the volume of a sphere. You'll notice on page 2 and 3, anytime it's a sphere question, they will tell you what the volume is of the question. But area of circles, circumference of circles, volumes of cubes, surface area of cubes, Pythagorean theorem, volume of cones, all that kind of stuff they do expect you to know. So I'll try to make a list. Let me start on this. And I guess you can use the calculator on these, but I don't know that it's really going to do much. Looks like for question 2 you need to know the volume of the sphere, so I did write that on the board for you. So again, the answers to the first 6 are down on the bottom of page 1. So when you finish one, if you did not end up with 8 pi square feet per second, and you don't see why, I need you to call me over to help. No, but you need to just make sure that you know why the units are that. Not that you're not. Don't just get them from there. Make sure that you know where the units
What's your number? Why is this part the rate change?
Because the radius is increased by 2 meters per second.
Right. Is it because, oh, because it's the rate of the radius
per amount of time.
okay.
Radius would just be a length. If it's how the radius is changing per time, it would be our time. Cone.
Oh.
Are we assuming the balloon's a sphere?
Yes.
Okay.
Volume of a sphere is one you don't have to memorize. They always give you that.
Okay.
I think these first 6
I
are
don't know, I
not
feel like
really.
this is kind of like weird. Assuming the balloon's a sphere.
Well, what else would it be?
Wait.
I don't know.
What's
Some
the pi?
Oval's 2-dimensional.
How do you, what would that be called?
Anything like Mickey Mouse has balloons or something?
No, like think about a balloon, it's not a perfect circle. Or a perfect sphere.
But that's a spherical balloon.
Yeah. So I'm not.
Weather balloons look like spheres. Party balloons, they've got the little nub at the end. The little-
Are you still stuck on number 1?
I haven't started it yet. I wonder if there is an equation for this, like a balloon. That little nut, that's the thing.
It's 1/3.
Oh, no, that's.
That's for the rate change. This is linear, or like flat.
Pi squared is, yeah, just like a circle. This is a sphere.
Mhm.
Okay. Oh, I forgot. That's just
That's why I went to see the bed. Every time.
Wait, I just did not. Wait, I just don't know.
We're not trying to find them.
Yeah.
Wait, or is it just like,
So we're gonna put it on the other side. So we
hold on. No, it's not. Wait, I'm not. Assume the coarseness of the gravel is such that R equals 8.
1/3 pi r cubed times pi.
Wait,
Hold
what'd
on.
you say?
1/3 pi r.
Wait,
What's the pi r?
cubed. Wait, no, pi r squared.
Squared.
Times pi.
How's girl on this one?
What are you going to do?
So the volume.
R.
Yeah. The derivative.
Well, it's so far it's not R equals H. R equals H. So I'm assuming
I think so.
You should not assume that r prime is 0. See what you did here? This is great that you thought of product rule. But since r equals h, if you just change this right here to r cubed, then you don't end up using some of the same information. Or h cubed. Anybody still stuck on question 1 or question 2? 1 or 2?
R and H are the same thing. Then you can just say snowstorm.
Question 3 is a little bit harder, but that's good for you to see where you get
So we do that, and then we can just find it.
Oh,
R, just then. Times R.
With H cubed, it does that. There's 1/3 is cancelled out.
Wait, what's R?
that makes it a lot easier.
R prime.
Would r prime be the same as h prime? Because r equals h.
I don't know where that would make that decision.
Right, because R is
I think I would have lost, but I don't think that's gonna matter. Let's shake and pitch and what's the volume of the cone?
Hold on.
Very good. Okay, so if you write that out, you can either change your r squared to your h squared.
Wait, do you think they're gonna be equal because they're
Yeah, or your, yeah.
they do? Oh, I haven't been volume. Wait, yeah, that is volume.
And see, you could have just as easily changed all of these to r's.
Wait, what are
The
you
problem is if you do that, you're never gonna be able to define
What's the formula
r
you gave
prime.
us?
Is it for area or
So that's
volume?
why you wanna switch them all to h.
Oh, we just read it wrong.
Did you combine the h and the r since they're the same to make it h cubed? Because R and H are the same.
Area?
R
Oh,
and
so you
H.
can just
Well,
combine.
Your description is H,
Oh,
it's just
so you
H
just,
cubed.
wow, you're a genius.
It is 1/3
So this can be
Oh, this is literally.
pi r
That's
squared.
why.
can be R cubed. So volume of the equals 1, right?
Yeah. So pi r squared.
R squared R prime. Now, equals right?
Wait.
Yeah. R prime. 1 over
Wait, this is. Wait.
Wait, we need to find H prime, so we should do H cubed.
So wait. I'm just kidding.
I got,
1 over pi?
yeah.
Okay. So then what's your whole answer?
Yeah, that's right, too.
Okay, so, yeah. So it's
Oops, feel like I'm gonna say
Wait. Oh, I just skipped.
Oh, stop. Oh wait, we have to find it.
R is like H, so I assume you would have to. I think so, yes.
I'm doing it right now, but I don't. It's just one of those where it's
Okay, again, I think number 3 is a little bit harder, but anyone still stuck on questions 1, 2, or 3 that I can come around and help with?
I have no clue what the formula is for number 3.
Okay, it's a cone, and the volume of the cone is 1/3 pi r squared h.
Well, they're the same thing. R and H, right? Well, so, oh, because they have to be the same.
Oh, Mr. Townsend. Question
They're equal. R and H are equal. See, it says that. R equals.
It's a triangle. It's like, so basically, there's a balloonish radius. The observer is here. One if you
Okay, so it's a cone. So what formula did you start off with?
How long?
How fast is this change?
Okay. Now, you could
How's that change?
take the derivative. Now, when you do that, Now, this is not a smart, this is not what you're supposed to do, but I want you to see that if you did this, why you should catch it. How do I take the derivative of this though? Okay, gotta be product rule. So, the derivative of r squared times h left alone, and the derivative of h with r squared left alone, right?
Yep.
So this is technically true, but if you look through your work, there's some of this that they just never tell you. Right? I think this is what you're trying to solve for. And I don't think they ever tell you how the radius is changing.
It's going straight up.
The radius is changing, and I don't think you ever have enough information to figure that out.
Oh, I don't know why I read that like.
So,
Never mind, that was
right here,
Oh,
It doesn't say
so
it's not
then-
the ground.
do you see how the question says,
So it's
right
going up.
here?
So it's going up. It's up 50 feet. It's 150 feet away.
The question says something like, for this particular tonic,
I was also.
or cone, r is equal to h. So you can either turn this into r's, just for this question. Okay. You could take the derivative of that, which would be power rule, and then r prime. What's wrong with that though?
That's the rate of volume, right, change?
It is, but we need that,
Oh,
or we know that. What are you trying to find in this question? Right, you're trying to find the rate of height change, and if you go this route, you don't have that to solve for.
What did you get for?
So instead of changing everything into r's, right, change everything into h's. So then, when you take the derivative, you actually have the thing you're trying to solve for. That's why that one's a little bit harder, because it's not just, you don't necessarily know.
Tell me what it is.
I would hope that you guys would almost do this, the product rule, because it's good for you to see product rules, sometimes you actually need to do that, but only that R equals
That's how far I got to that, but I couldn't figure out how to get past that.
yeah, because you didn't have enough information.
You guys get their C. We're working on that.
I don't know, R prime might be equal to S prime.
Yeah.
I'm not comfortable.
I know what it ends up being.
Just because R equals like the rate of means that rate is zero.
right. Because, yeah, it's so good. That's 0 plus 450.
Wait, do you know what it was? Square root of what?
Yeah. Yeah, we're trying to find. What is the
So then that's.
Is your brain working now? No?
No.
I thought I did 4 right, and then it's like, haha, no.
Well, let's see what you
Okay,
got.
I'm confused.
So,
Other.
5 squared.
So we need to close this.
No, that's right.
letters 26 feet, and it wants me, the rate is 4 feet per second. And it's 10 feet away from this wall, so
5.
I got the derivative of Pythagorean theorem, plugged in what I knew, and then I did the Pythagorean theorem to see what V is.
Yeah.
This is 10 and this is
50
26.
squared is 10.
But it says.
The square root of 26 squared is 6.
Oh, I see what it
So.
means. So yeah.
I can't do that in my head, I don't know. Or not quickly.
Yep, that's right.
You're right.
Let's go.
Root of 576.
So
I get 24 for the other side.
Oh, wait.
And
That'll be
then
fun.
you have to read. What is this?
Leg squared plus leg squared.
Well, it's 26 squared.
Hypotenuse squared.
Wait.
Your leg should be 10 and 24.
Oh.
So that's had a mistake in that.
Wait, did I see yours?
Yeah.
I'm doing something wrong.
152.
Well, is it?
You don't like my calculators?
I remember that.
There's like 2 minutes.
Oh, it is.
2 minutes?
I was exaggerating. There's like 5. There's 7.
I think that's right.
That's a big difference.
We're not all perfect like you.
That's a 350% difference. I haven't asked for it yet. Oh, it's in Google Classroom. Part of your homework is turning it into Google Classroom.
Oh, I don't see it, like the assignment for
Oh,
it.
did I not unlock it?
I don't think so.
It's already changed of seat. Where'd C go?
Can you solve the sphere?
That's what we're solving.
I don't need to. I got y'all to do it for me.
Wait, but I'm doing something wrong. Because we divide 400 feet divided by 50 square roots of 10.
It should be because we're just
But you got 4 square roots of 10 over 5. Did you get number 5 in there?
Hold on.
How did you get the 10 on top?
No, I got the 10 on top. How did we get 4 over 5?
Did you rationalize it because he doesn't have the... Oh, wait, let me try this.
Wait, how did you get the 10 on top? Never mind.
I was like, how did you get to tell them?
I was just trying to cut it down.
This is an A week?
Yeah.
Oh, I figured that out. Of this. You apply the bottom and the top one. Square to 10 minutes away from the bottom. And then, so,
400, yeah, no, I think you're right.
100
to 10 over 50 times 10, which is 500, which is 4 over 5.
500, which is 4 over 5. Let's go.
Did you pass your calculus exam?
I didn't take AP Calculus in high school.
Oh.
So you'd have to do it.
I was not crazy enough to do calculus in high school.
Oh, yeah, you were. I remember you saying.
So you'd be left with 40 roots.
Are you calling me crazy?
There's no way.
Yeah?
Forgot about the whole bachelor.
Me too.
It's not my best moment.
I'm so scared for my essay.
When is the
Like exam next week.
Oh, I know. Carly was so good. She's a little You are.
The neurotransmitters, I know some of them.
That's like that one and Unit 3 essays.
Alright guys, we are down to 5 minutes, so you need to find a stopping place. Just to be clear, this number 41, you do not have to do any of this for homework unless you feel like you're struggling a lot and falling behind, and then it would be good for you to do a couple. I will give you more class time to finish that up. But I do expect for homework, it's on the agenda page there, I need the homework from last class turned in. So before I see you guys on Friday, you should have time to turn that into Google Classroom.
I don't know how to do this.
X to the...
You don't like it?
Okay, so you could do this. Okay, you could take the natural log of both sides. The reason why that would be helpful is now this is an exponent on something you're taking a log of, so this exponent can come down out front.
Just because, like, she seemed like she was abrasive. Yeah. But, like, I started going to the library and
Okay.
just for fun.
So
And she's like, so,
I see,
she's
like, swipe up.
now it's okay.
Then
Now
I
you
feel
can
like
do the
I-
derivative of this one we have memorized. That would be 1 over y, y prime.
But all English teachers always
Well, I still realize.
You're going to have to do product.
she's such a
Okay.
You could rewrite this as 2 times x to the negative 1, but you're still going to have to do a product
Research
rule.
paper, they did not grade that.
Like, I have to do quotient rule and then product rule.
Well, if you rewrite this as 2 times x to the negative 1, you don't have to do the quotient rule.
Okay.
You could just use the product rule and write it like that. You know where to find the videos of these online?
Can I still see
Yes.
them? Okay.
So I'm just saying, because I don't have time to help you finish it, but you can watch that to finish it.
It's just, it's probably still in the drawing.
My essay was like
Yeah, me too. If you write about something you want to actually.
yeah, then it's like you do something better. I'm so glad I picked the topic I did. What did you get at? I think it's like these measurements basically. And but I also like you have to do counter arguments